So we just went through finding some limits at infinity, which basically means we're trying to find end behaviors. And so a graph may level off at a value, it may go up to infinity, it may go down infinity. And it kind of depends on the situation that you have. Last couple of examples that we did where we were talking about polynomials. And so polynomials have, they don't level off, they're either going up or they're going down, and it's all kind of dependent upon the power. Do you have an even power? Do you have an odd power? Positives, negatives? And we kind of narrowed it down to refresh your memory on even powers kind of have a quadratic end behavior to it. If it's positive, it's going up. If it's negative, the leading coefficient, we're going down. And if an odd is kind of like a linear, so it has a positive slope or negative slope depending upon the leading coefficient in front of it. So that doesn't really work with rationals. Now we learned some ways to do it, and we're going to kind of talk about that answer after we get through this. But when we're doing a limit, we still have to be plugging a value in, right? And so if we're going to be doing the limit as x approaches infinity or x approaches negative infinity, we're just going to focus on positive infinity on this one, that we need to plug it in. And so we're going to be trying to do, so for calc, we need to plug in. Need to plug in positive and negative infinity. And so we're going to specifically do the limit as x approaches infinity. Okay, well, we have a bit of a problem actually on that. So 3x plus 2 over x squared minus 1. So if you just plug it in infinity, you're getting infinity on top and you're getting infinity on the bottom. Now we can logic our way through this that one of these is going faster to infinity than the other one. So that's going to play a role in our answer. But let's not logic our way. Let's show how we can actually do the math to figure this out. So here's the kind of the thing that we're going to do is we're going to manipulate our equation so we can plug in an infinity and get an answer. And so we're going to divide each term by the highest power in the denominator. All right, so here's what I mean by that. X squared is our highest power. So we are going to rewrite this thing as, let me rewrite it right here. We're out of space. We're going to take every single value and divide it by x squared. So that means this is going to be 3x divided by x squared plus 2 divided by x squared over x squared divided by x squared minus 1 over x squared. So we're just manipulating it. It's kind of like if we did distribution, we distribute to everything. So we're dividing everything. And if we simplify this, we're going to get the limit as x approaches infinity. I can't drop those until I actually plug in infinity. So this becomes 3 over x plus 2 over x squared over 1 minus we got 2 over x squared. So that one doesn't simplify. Okay, so if we now take this and plug in infinity, we would get 3 over infinity plus 2 also over infinity, because infinity squared is still infinity, divided by 1 minus 2 over infinity. All right, so here's what happens. 3 divided by something that's getting infinitely large essentially goes to 0. This goes to 0, and this goes to 0. And so you're left with a 0 over 1. So that gives us a limit of 0. Let me pre-calc this thing for a second. If we were in a pre-calc class, we would be talking about an end behavior. And so our end behavior would be what's happening to this graph when you plug things into the right or to the left. Horizontal asymptote, essentially, is what we're talking about. So if we're looking at this, we're talking about, well, your power on the bottom is bigger than the power on the top. So then that tells us in a pre-calc class, you have a 3x plus blah, 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 over an x squared minus blah, 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 that higher power in the denominator. So then our horizontal asymptote would be at y equals 0, which 100% agrees with our calc way of doing it. But we have to, in a limit, we also always have to plug in a value. So we have to manipulate this in a way that we can plug in a value to actually justify that we're getting a value of 0. Right? So if we do this again on these next two, we have x to the fourth is our highest power. Well, let's just pre-calc it for a second. If we pre-calc this for a second, pre-calc is telling me that my horizontal asymptote, when the powers match, are just going to be my leading coefficients. So it's going to be y equals 40 over 10, which is just going to become 4. Right? Well, let's justify it with the calc. And the calc is, we are going to divide every single piece by x to the fourth. So we're going to have the limit as x approaches infinity. And then the same thing we would be doing if we did the negative, same process, but we're just going to focus on the positive. So we would take 40 divided by 40 x squared divided by x, sorry, x to the fourth divided by x to the fourth plus 4x squared divided by x to the fourth minus 1 over x to the fourth. And then we would divide it by same thing on the bottom, x to the fourth plus 8 x squared over x to the fourth plus 1 over x to the fourth. All right, so then we simplify everything. Limit x is going to infinity. So we have those go away. You're left with 40 plus 4 over x squared minus 1 over x to the fourth divided by 10 plus 8 over x squared minus 1 over x to the fourth. All right, so now we're ready to plug in. So if we plug in, now I can drop my limit. Sorry, paper was too low. Now we're plugging in our value, so we're getting 40 plus 4 over infinity minus 1 over infinity. So those are going to zeros, divided by 10 plus 8 over infinity minus 1 over infinity. Those are going to zeros. So we are left with 40 over 10, which is 4. Right, so we would do the exact same process if we were doing negative infinity, dividing everything, plugging in negative infinity, and we would still get that same thing. So our overall horizontal asymptote, pre-calc wise, is y equals 4. So in both directions, we are approaching 4, and at least to the right, our calc agrees with it. All right, and then let's do one last. That pre-calc. I don't really know. I have a x to the third over a 2x. So these things differ by more than 1. If I know that they differ by 1, we're going to have a slant asymptote, which we'll talk about in the next one. But I don't know. But so we're still going to take the exact same approach. We'll do the limit as x is approaching infinity. And we're going to divide every single piece by x. So we're looking at x to the third divided by x minus 2x divided by x plus 1 over x divided by 2x over x plus 4 over x. Right, so our limit as x approaches infinity, let's simplify this. We're looking at an x squared minus 2 plus 1 over x divided by 2 plus 4 over x. And now we're ready to plug it in. So if we plug it in and we plug in infinity and square it, right, that's giving us an infinity. Minus 2 plus 1 over infinity, which is going to 0, divided by 2 plus 4 over infinity, also going to 0. So that overall is going up. right? And so I could do the same math with the negative infinity. We would be sitting with this, and then I'd be plugging in a negative infinity. Negative infinity squared is going to be also going up, right? Because that stuff goes to 0, and the 2's kind of play a pretty insignificant role when you're talking about infinity and subtracting 2. So your power is going to matter. And then if you kind of really go back to the very beginning and start talking about it, the numerator is moving faster than the denominator. So if you plug in a positive, you get a positive cubed, an infinitely large positive over another infinitely large, but that cube is much bigger than that. So it's positive divided by positive, which agrees. If we plugged in a negative, we'd have a negative cubed. So that would be a negative over another negative, keeping you at still a positive infinity. So there's a lot of other logic that goes into it, but here's kind of the calc to support our answer to it. All right, so that was just doing the right side of it. The left side, doing the negative infinities, would be the same thing. And then we'll go specifically into how do we deal with the fact that it has a slant asymptote. We'll do that on the next video.